Okay, let's talk about caliper fundamentals. The first thing you want to assume about a pair of calipers when you pick them up is that they're dirty. Notice how I'm holding the calipers with a light source behind me. And notice how I can see light coming through the jaws. That thin line of light sneaking through is a bad thing. And if I look really closely, I can even see the culprit. See this tiny little chip near the end of the jaws? That's holding them a little bit further apart. They're not making complete contact with each other. So whenever you pick up a pair of calipers, assume they're dirty, open up the jaws, and just wipe the face of both jaws with your finger. Then close the jaws and confirm with a light source that no light is sneaking through. Once they're clean, look at the problem here. When closed, the caliper is now reading negative 0.002 of an inch. If I let this ride, every measurement I make with this tool will be off by 0.002 of an inch. So the next step is to zero the caliper. In its clean and closed state, push the zero button to reestablish where zero really is. Then open and close the caliper several times to confirm that you can re-arrive at zero successfully. Good, now deflection. You have the power to deflect the jaws of the caliper if you push too hard on the thumb wheel. Watch what happens to my measurement, which is currently 2.9835 inches, if I add more and more force to the thumb wheel. I am able to change this measurement down to 2.9765 inches. That's a change of 0.007 of an inch, which is a lot. So what's happening? Well, as I am adding force into the system, I am deflecting the jaws of the caliper outward and allowing the measuring part of the caliper to slide a little closer towards zero. This is bad. It's inaccurate. There is always the potential to add too much force to the thumb wheel. So practice a light touch, just enough to close the calipers, seat them properly, and deliver consistent measurements. So how do you practice this technique? Grab a gauge block. Grab the largest one available. Gauge blocks make a fantastic promise. They promise to be more consistent than your measuring equipment. And they promise to be very, very parallel across any of their two flat surfaces. And as you're getting started, notice the jaw design of calipers. The contact plane on the jaws stops here, and then there is a relief. So when doing measurement, you don't want to measure tight up against the plastic enclosure of the electronics. You want to be on the contact plane of the jaw itself. To test yourself, start with the assumption that these two faces are very parallel, and so they should always deliver the same measurement. Then stand the gauge block up on end so that you have a comfortable way to make several measurements down those parallel faces. What you're looking for is the light touch and a consistent measurement. Here I'm getting 1.3755. Most of what I'm up to is practicing seating the calipers, because if the calipers are not seated properly, imagine that the jaws are not landing flat on those faces. That's going to throw off my measurement. Seating the jaws properly usually takes a bit of a wiggle. You're wiggling up and down with a little bit of force on the thumb wheel, allowing the jaws to arrive at that plane of perfect contact. First, practice seating the jaws. Open and close them, wiggle them, and seat them until you can get a consistent measurement every time. Then work your way down the length of the gauge block at 3 to 5 locations along its length, asking, can I also get consistent measurements at each of these different locations? This takes finesse. It can be so tempting to just add force to the thumb wheel, deflecting the jaws outward into an inaccurate measurement to get the number you want. Practice consistent light touch on the thumb wheel, and your caliper work will start to be useful. Why measure at 3 to 5 locations along a bit of geometry that we're interested in? Well, look at what happens when I measure something that's not precision ground to be a gauge block. At one end, I get 359. In the middle, I get 353. And at the other end, I get 360. If I trust my ability to use a caliper accurately, then I can now say something interesting about this block. It is in no way a gauge caliber block. Rather, it's something with a pretty significant bow in the middle. And if you're wondering, do I really need to be concerned about 0.007 of an inch? Well, if you open up Machinery's Handbook or the Engineer's Black Book, you'll see a chart on the allowable tolerances whenever you want to component tolerance to move successfully. And the units of this chart are in thousandths of an inch. And even the sloppiest fit listed on the chart only has a tolerance of 5 thousandths of an inch. Which lets us say unequivocally that yes, a difference of 7 thousandths of an inch really matters. Another gotcha when measuring with calipers are burrs. If you measure on a burr instead of on the geometry of your part itself, you're going to end up with a significantly different measurement, and that might spawn an idea in your head that your part is quite a different size than it really is. Even this smaller burr here, where the drill exited the material, if I measure on it, will suggest that my part is 8 thou bigger than it really is. You can measure cylinders the exact same way. Use a light touch and seat the jaws of the caliper. And you can measure inside dimensions using the inside jaws of the caliper here. But keep in mind that using a caliper to measure the inside of a cylindrical feature, the inside of a round, is inaccurate. I can do it. I can get a number, 0.214. But look what happens when I cross-check that measurement with a pin set. Yes, the 2.14 pin fits, but it's very wiggly. And it's not until I work my way all the way up to the 218 pin that I find the actual dimension of my hole. What's going on here? Why is there such a discrepancy between measuring tools that are supposedly accurate? Well, think about the hole itself. If you look down the axis of it, you'd be seeing a circle. It's round. Now think about the jaws of the caliper. They almost look sharp like a knife, but they're not a knife, they're a measuring tool. And so instead of a knife edge, they have a small flat at the end of each jaw. Now zoom in and imagine what's going to happen when that flat makes contact with the arc of the inside of that round. The left and the right of the flat are going to bump into the arc, and it's never going to reach to the highest point of the arc. And as the cylinder that you're trying to measure gets smaller and smaller and smaller, the bigger this gap is between your measured dimension and the actual inside dimension. The more a caliper becomes an inappropriate measuring tool for determining the size of this inside dimension. Good. As you work with the calipers, you're going to notice that there are 4 digits to the left of the decimal point. But the last one, the 4th digit, you should ignore. It will flicker between 0 and 5. It is telling you something, but I would never write that number down. I would stop at 3 digits to the right. Thousandths of an inch. Lastly, we do have a coolant-proof caliper near the mill. Save this one for only when you're reaching into the mill and coolant is still dripping down from the nozzles. This one is more expensive to replace if it gets dropped, but the others will immediately get destroyed if a drop of coolant gets into the electronics. And as always, stow the calipers back in the drawers when you're done so the next person can find them.